So this is 2012, number 80. And note, derivative. This is the derivative. I'm going to make that super big so we don't forget. That is the graph of the derivative. Which of the following statements must be true? Not might, it has to be true. So the first one, f has a relative minimum at -3. What is the justification for a relative minimum? The derivative changes from negative to positive. Here at -3, what's the derivative on this side? It's negative. What's the derivative here? It's positive. So does it change from negative to positive at -3? The answer is yes. So that is true. Remember those justifications, those quizzes we had over and over and over and over? It was all based on that. Is my screen lagging? There it goes, just caught up. All right, next thing. There's a point of inflection at -2. Okay, a point of inflection. Here is where it's very important to know your justifications. The justification for an inflection point is the second derivative changes signs. Okay? Now, some people might say, oh yeah, look, there's an inflection point here because this is concave down, that's concave up, inflection point. No. This is f prime, this is not f. F prime has an inflection point right there, but that's not what it's asking. So you have to go back to your justifications. You have to think, how do I prove an inflection point? The second derivative changes signs. How do I know if the second derivative changes signs there? Well, this is like where if you had more time, I think you would do better on these, but hopefully you're paying attention. This makes sense. In this region, you should notice what? F prime is increasing. And what should you notice here? On that region, you should notice F prime is decreasing. Back to your justifications. If any function is increasing, you should know its derivative is positive. That's basic. So since F prime is increasing, its derivative, F double prime, must be positive. Now, looking at the other side, here, F prime is decreasing. We know if any function is decreasing, its derivative is negative. Therefore, the derivative of f, which is f double prime, must be negative. Okay, conclusion. The graph is concave up on the left side, and the graph is concave down on the right side. So the only place where the second derivative changes signs is at 0. There's an inflection point at x equals 0. So there is not one at -2 because the second derivative is positive on that whole region. There are no inflection points there. So that is definitely a false statement. Okay? All that reasoning needs to make sense to you guys. It's going to be a common thing, especially on FRQs. Part 3. The graph of f is concave down from 0 to 4. Well, we already did the work. The second derivative is negative on this whole region. Well, therefore, true, it is concave down from 0 to 4. So that is definitely a true statement. So 1 and 3 are the true statement.